Okay, the goal of this video is to solve questions about how to set up circuits with tinkerCAD. We have this circuit right here, and we have all these values to find out. So first of all, we have to mount the system. Let's start with our basic devices. We have a power supply, a multimeter, and a breadboard. First thing, we need resistors. One, two, three, 4, 5. Okay, let's see what is needed. First of all, we have R1 and a node. Okay, then we have R2, R3 parallels. And R4 and R5 in series. Okay, this is the bare bones. Now we have to make some lines to link them. First thing, let's link this node to the positive line. We can assign this red. Now this little thing needs to be in the same node as R3. See, because this node from, R2. So R1, same node as R2. Okay. And R2 and R3 also come from the same node. So we need to link those two. Just for us not to get messy. Alright, those two are linked now. Last thing, R3 and R4 also come from the same point. So this is R3 and this is R4. We need a link between those lines. Done. Sorry, this is wrong. Now we need to put those guys in series. You can do this, but just so things get distance and you can get a good picture of it. I like doing it this way. It's totally wrong, not conventional. We are still going to get the questions right. So R5 connects to this last node, last line right here that goes to B, and also R2, also R3. So I'm gonna do this. Okay, this is better. I'm gonna do this. Now we have this node free to connect things to. I'm gonna first connect this. Now those are linked. And now I'm gonna connect these two. Done. And lastly, we need to close the system. This thing can go right to the negative pole. And I'm gonna put it black for convention. Okay, this is the circuit. We have to assign values now. I have a cheat sheet somewhere with values from the question. So let me get it. I love when it glitches. Okay. R1 is 1.8, R2 5.2, R3 9.5, R4 7.9, R5 8.1. Okay, that's the circuit. Lastly, but not less important, I need to connect these things. So okay. Forgot these values. This is true. We're not gonna assign any current for now. Okay, the system is running. To see if everything is working, and also to get the first question, we need to get R1, I1, and V2. So let's first get R1. To get the resistance, we need to put things in the multimeter in parallel. And it didn't work. This happens because we are still running our circuit. For this to work, we need to cut the power right here, allow one thing to flow in, and we get a result. It happens to be just right, because that's the resistance. The question right here is not about the resistance, it's about the equivalent resistance. In other words, the resistance of the entire system. To do that, instead of putting this in this point right here, we put it right here at the end of our system. Result 4.58, result 4.58. This is how you measure resistances. You need to put things in parallel with the object you are taking the measurement from. Second thing, we need voltage. Voltage works just like resistance. In terms of measurement, we need to put it in parallel with the object we are measuring. It didn't work because now we have this off. We need to put our power supply in. To get a measurement. Why? Well, I don't know. Ask your teacher. I'm just gonna measure it to get the question right. So this is 1.18. Next, V2. V2 is the voltage on R2. So stop the simulation. We go to R2. Put our terminals right where they belong. And ask for a measurement. 1.82. And just write 1.82. Next, we need V3, which is right here. So I look for R3 and take its measurement. And you are going to notice something interesting. the measurement from R3 is the same as the measurement from R2. That's one of the properties of these things being in parallel. Next one, R4. Oh, sorry. Next one, R4. Same thing. Just need to put it in parallel. Oh, I was scared for a moment. Okay, this is V4, 0.90. We have 899 microvolts, so yeah, we can just put it a dot and call it a dot 9 and call it a day. Next. (921) or dot 921 volts here. Next, we need, oh, we are actually going to start the currents now. So currents are a little bit different. To measure a current, we need to cut the system because we want the current to go into our multimeter and then back to the system. So if I did it correctly, we should be getting a correct answer of 655. And it's right, 655. No idea where that 0.42 come from. We need I2 now, which is right after R2. So R2 is right here. The current comes from I2. That's here. Now I need to cut the system. Can I do this? No. Okay, I had an idea. Current is coming here. Current comes back from here. (350) microamperes, 350. So what I did here was the following. I hijacked the current from this point, and since I didn't have much space, I just decided to give it back here. Now I need to get this point and bring it back to our system. Here is the node where everything connects. In our graph, it's this one, this line right here. That being done, I got the measurement right, we can move on. I2, 350, I3 from R3. Similar situation. Let's undo what I just did. Okay, now we hijack the current from here. And give it back here. I'm not sure if this will work, but we will try. I have 192.191.60. I have no idea where my teacher got these measurements from, but it's good enough. Okay, I'm hijacking the current here, so it's like I cut this point entirely from the system. Now I need to give it back, and similarly to this image, I'm giving it back right here, so everything flows correctly. Next, I4. Let's undo what I just did. R4 is right here. We need a system. This one is easy. It's the easiest because we're talking about series systems. So I just need to delete this, hijack the current right here, and give it back where it belongs. And just like that, we got 1 on 4, which is 1 on 13.77. Yeah, I think these measurements are actually from the real world. Since we are not losing anything in the system, the measurements are a little bit more on point. And I5, well, since I4 and E5 are in a series, the current is just going to be the exactly same. And I'm going to show you that. So if I want this, I just need to hijack this and give it back here. In other words, I'm just going to delete this and make the bridge with these guys. 1 on 14, and it's the same. Just like that, we got our assignment done, and God help us all during the test.